Hello everyone, my name is Silvan Maniraj Hun. This is my third assignment video on energy methods, and today I will be calculating the final velocities of an object using the energy method. Here's our problem statement. A crane is holding up an 8,159 pound empty shipping containment 400 foot in the air. And as it's transporting the containment, however, ooh, the crane malfunctions and drops the container to the ground. And we are to find the velocity of container as it hits the ground. Here are some assumptions that can be made. First off, we can assume that there is no air resistance acting on the container as it falls, so there will be no energy losses due to the drag. And we can treat this system as a perfect system, so that means that there are no energy losses in the system. And finally, the only thing that will be acting on the container as it falls is the force due to gravity. And with all these out of the way, we can apply the principle of conservation of energy to find out the velocity of the container just as it hits the ground. Here are the concept and solutions. Using the principle of conservation of energy, we get this equation right here. The starting kinetic energy plus starting potential energy equals the final kinetic energy plus the final potential energy. And even though the system only shows a rectilinear motion, conservation of energy does not depend at all on the path a particle takes to get from the starting point to the end point. All that matters is its mass, the force through gravity, and its height. And here are some given. We are given the weight of 8,159 pounds, and we also have gravity, which is 32.2 feet per second squared. And here are the starting conditions. The initial height is 400 foot in the air as it was still connected to the crane, and its starting velocity is also 0 foot per second because it was at rest before it fell. And the end conditions will be the final height, which is will be equal to 0 foot because it's on the ground, and the final velocity is what we are looking for. And here we are solving for the final velocity. Using the equations we had before, using the principle of conservation equation we have, here we have the starting kinetic energy, which is 1/2 mass times the first velocity squared. It will be equal to 0 because the initial velocity is 0. The initial potential energy, which is mass times gravity times starting height, which will be the weight times the initial height. And for the final kinetic energy, it will be 1/2 mass times final velocity squared. And here will be its equation, which is 1/2 the weight divided by gravity times the velocity, final velocity squared. And the final potential energy will be mass times gravity times the final height, which will be equal to 0 because the final height is 0. And once we plug all of that into the equation of principle of conservation energy, we find that the final velocity will be 160.5 foot per second. Thank you very much for watching this video, and that's all I have for you today. Thank you.